Let's take a look at the ladder diagram format. Now, as we know, the ladder diagram language is a symbolic instruction set composed of contact symbols that are used to create a programmable controller program. These ladder instruction symbols can be formatted to obtain the desired logic necessary to provide control. As we can recall, the ladder diagram is also referred to as contact symbology for obvious reasons. The main function of the ladder diagram program is to control outputs and to perform operations based on input conditions. This control is accomplished through the use of ladder rungs. Ladder rungs consist of one or more input conditions represented by contact symbols, and in general, one output instruction represented by the coil symbol or a block with one or more coil symbols attached to it. A ladder rung is said to be true or to be energizing an output or functional block instruction when logic continuity exists in the rung. Continuity exists when power is provided from left to right in the rung. The left side forms a rail that simulates the L1 line of a relay ladder diagram, which signifies the hot line or power of the circuit. The right side or rail simulates the L2 line or common of the electromechanical relay ladder circuit representation. Power continuity exists in a rung whenever a path contains contact elements in a closed condition indicating that power is flowing. The state of an open contact that has closed and is thus providing continuity is represented in PLCs in a highlighted form. The same applies for contacts that are closed to start with, that is, contacts that are normally closed. If they are still closed, providing continuity, they will also be shown highlighted. If no continuity exists by a contact element, then it will be represented without being highlighted. As we know, the status of a field input device will determine whether a contact reference, either the normally open or the normally closed, will be providing power continuity to turn an output on. Again, power continuity will exist if any one forward path from left to right is present. Now, one rule that almost all PLCs have is that no reverse power flow is allowed. So if contacts F, D, B, and C are on or closed, providing continuity, the output Y will not be turned on because of the reverse flow that is present at contacts D. Reverse power flow is not allowed in PLCs, primarily to prevent possible sneak paths that could occur in hardwired electromechanical relay systems. If you want reverse power flow conditions to be present, then you'll have to program those conditions in your rung using a forward path. When functional blocks are implemented in a program, the input conditions, also represented by contacts driving the logic, will determine if the block function will be executed or not. That is, if power continuity exists, then the functional block instruction will be executed. As we'll see later, functional block instructions may have 1, 2, or even 3 output coils to signify certain conditions of the block instruction execution. The maximum number of ladder contact elements that can be used to program a rung is restricted by what's known as the ladder rung matrix. This matrix size differs among manufacturers, and it may also be limited by the programming device being used. You would obviously be able to program a larger matrix and personal computer than a small handheld mini programmer. The matrix size may also be limited depending on the number of input lines to the block instruction, such as enable and reset.